Hi, Tim Graves back here again, looking at some more of the things that we can do with Helidon. So what we've looked at so far has been about getting services set up, talking to the databases, securing them, getting services communicating to each other. But we also need to consider that code doesn't just run by itself. It runs in an operational and a deployed environment. So what is there in Helidon that can help make it easier to run the code and understand what's running and actually happening in that production environment? Well, this is important because, especially nowadays, when developers and operations are effectively being merged in the DevOps model, the person who writes the code quite possibly is the person who's going to have to get up at 3 a.m. on a Sunday morning to fix it. So you want to make sure that you've got as much information available as possible to do that quickly. Of course, you should have done this already to make the life of your operations team easier, but obviously we know that life isn't always like that. So first of all, we're going to have a look at how we can do tracing with Helidon, and then we're going to look at some of the things that I'm calling cloud native support. So this is basically stuff that makes Helidon work better in a cloud native environment, specifically in a Kubernetes environment. So to start with, tracing. Well, we quite often want to see what's happening when a request is made, to see which steps that request goes through, and to see how long each of those steps takes. That's actually quite a good example for understanding where there might be a problem. Now, Helidon has built-in support for tracing, but we do have to enable that, and that's a couple of things to do. Now, first of all, we need to import the POM configuration file. So if we have a look at our POM configuration file here, and if we go down and we find the zipkin, you'll see that actually in the case of this code, it's actually just commented out to make life easier. But basically what this does is this will bring in the configuration library for zipkin. So that's for the stock manager, sorry, the storefront. Let me just do that for the stock manager. Okay, it's in here somewhere. Right, so now what we've done is we've included in our builds, Maven will do this for us, the Helidon zipkin library. Okay, we don't have to do anything more from a code perspective, that's automatically done. But what we do need to do is we need to tell Helidon where to send those traces. So again, there is some configuration information here. And what we're going to do is we are going to, so in the configuration file, we need to specify that we're using the tracing service. So this is the name to use, and then the tracing host, which is the one to do there. So that's already set up for the stock manager. Let's just make sure that's also in place for the storefront. Yep, so that's in place. And in this case, any traces from the storefront will be starting SF. Any traces from the stock manager will be starting SM. So that's just how we can differentiate which part of the service they're sitting on. Now, one other thing we're going to need to do is we're going to need to run a zipkin environment, which will accept and process those requests. So what I'm going to do here is I already have Docker installed and running in this virtual machine. So if I, oops, come on computer. So if I copy my Docker run command, okay, so we're going to get the latest version of Zipkin here. It's going to pull down the Zipkin image, and then it'll just start running it in the background or in the task there. Okay, so that's now running for us. So if we start making a request, let's start our stock manager service first, because obviously that's the one that we are talking to. Okay, oops, sorry, we actually already had a previously running one. So let's just go and kill that one off first. Okay, let's have another go. Right, run stock manager. Okay. And now let's run the storefront service. Okay. So as part of a startup, Helidon will recognize that we have bought in the Zipkin tracing files. There are others, of course, you can use Jaeger or Open Tracing. Zipkin is just a convenient one for me here. And I'm just going to make a quick request here. So this is going to go and get our stock information. Now, that's going to take a few seconds because we've got to do some dynamic startup here. And I'm actually deliberately expecting it to take a second or two to reply because that's going to show some useful information. If I now open up my web browser and we go to the Zipkin port on my local machine. Okay. So this is Zipkin. I'm just going to run a query to get all of my traces, and you can see that there was a trace that was generated a few seconds ago. It started off with an HTTP request into Zipkin, and it took 16 separate steps. So let's just go and have a look at that. We can see a bit more trace information there. So this is the steps that were involved in this. So the overall request took nearly 6.5 seconds. Now, obviously, this is really painful. But when we actually look into this, we'll see that the bulk of that time was spent in the stock resource code. So let's just expand that window a little bit so we can see a bit more on this. In the list or stock method. So is that just a one-off? Let's go and have a look. We're going to make another call to that request. And of course, now, because we're not doing the lazy initialization, that's much, much quicker. If we go back to our front page and do another search, we'll see that this second request came in at less than half a second. So if we have a look at that request, we can now see, again, it spent a fair bit of time making that list or stock request, but it was a lot quicker. We can see the security responses. If we were going to an external security system to do the authentication, obviously we would see the connection there and it would take a lot longer. We can have a look at the individual sections on here, so we can see what the request result was, but it successfully returned there, and other pieces of information. Now, I'm not going to be teaching you how to debug your code because obviously your code is different from my code. But what it does do is it shows you a fair bit of information here, and you can see more information about start times and timestamps and so on if you want to go into it in more detail. Now, how does this work? Well, basically, the first request that is received generates an identifier, a trace ID, and that is automatically propagated for you along all of the various stages of the request. So each stage of a request knows to inject that identifier into the previous stage. So Zipkin tracing systems in general, really, really useful at doing this kind of thing. But they're only telling you what's happening in terms of the performance environment. What they're not doing is they're not telling you, for example, metrics information, statistical graphs, and so on. So what we're going to do now is we're going to make a slight change to our code so that we can start generating metrics information. Now, metrics is slightly different, okay? Metrics is information on counts and stuff like that we have generated in our code. Okay, so if we go to our storefront class, where's that gone? Okay, so here is our storefront class. And what we're going to do is we're going to tell Helidon that we want to count all invocations. Okay, so we're just going to put another annotation on here. Oops, storefront, come out. Storefront resource, my apologies. So we're just going to say @counted. Okay, so nice, simple, single annotation that we just put in place. Helidon's metric system will automatically detect that and will now start keeping track of every time we call a method in Helidon, or in this class, so that we can keep track of what is going on there. So there's a bunch of other annotations that we can put on here, by the way. This is just a really, really simple one, just to start the process off. So if I now restart the storefront, so that's now running with that additional piece of code on it. Okay. Now that will start counting every time we make a request. So first of all, let's go and have a look at that. So HTTP. So please notice I am now going to a different URL. You may recall in one of the earlier labs, we split the administrative functions from the operational functions. So metrics is deemed to be an administrative function in this case. Okay. So now we have got access to all of the requests. There's a lot of information that is automatically generated for us. You can see requests per second rate and stuff like that. We can see, if we look further up towards the top of this information dump, that we've got quite a lot of information regarding the use of the JVM and so on as well. But you can see here that we've got the number of total counts, list all stock and stuff like that. So let's just make a couple of quick requests to gather information. 4, 5. And if we now get the metrics information back, we can go back up to the top here, which is where that information was held. And you can see that we've now got 5 requests. Now, all we're doing here is we're counting the number of requests. Now, there are a lot of other requests that we can put in place here, okay? By the way, if you don't want all of this information, you can restrict a little bit to just metrics from a particular application and so on. You can also drill down to a specific metrics field if you have named it. So in addition to the counting information, we can do things like understand how often something is called or how long it takes when it's called. So again, if we go back here, we can put a counter on here. So what I'm going to do is on the list all stock class, I'm going to put a couple of specific pieces of information, right? So first of all, we are going to put a named counter. Then we're going to put a timer. And then we're going to do a meter, which will give us the distribution of timed calls and so on. So please notice I'm giving these a name. Now, this is pretty important. If we don't give them a name, it will try and generate it based on the class and the method name. Now, unfortunately, it doesn't say this is a counter for that class and method, or this is a timer for that class and method. It just uses the class and method name, and that can result. Stress can result in conflicts. So obviously you don't particularly want to do that. So we want to put a named counter on here. So let's just save that, run our piece of code again. And now if we make calls to our code, get the metrics again, we're going to see that we've got some extra information here. So we've got rates per second broken down over an average of 1 minute, 15 seconds, 5 seconds, and so on. We've obviously got the total number of requests and so on. Now, there are a number of ways you can do this. You can also even do things like count how often a request is actually still in progress, which is potentially also useful as well. Exactly what data you want to get is, of course, up to you. Now, if you want to, you don't just have to get data from Helidon. It is possible for you to access the metrics and to create your own counters and own tracking things. So, for example, if you are a financial services, you may want to track the total financial throughput of revenue through a particular method and so on. So there's a whole bunch of options that you can do here, but ultimately what you've got is the ability to track and see exactly what is happening. Now, there is another set of services and capabilities that we can do within Helidon to support the cloud native environment. And these are pretty easy to do. So effectively, in a Kubernetes environment, Kubernetes has mechanisms to detect if a service has failed, and it will automatically restart it. And that's pretty easy because virtual machine, in our case, has just exited. But what happens if a process is running, but maybe it's deadlocked? So what we're going to do here is we're going to have a look at a couple of additional resources and additional elements here. Now, these are just done by just adding an annotation, right? So the health resource is a generic catch-all for all of this. And see if let me restart my process again. Let's have a look at the health endpoint. Okay, right. So you can see it does some basic reporting information. This is effectively a quick summary of what your metrics would be, but at least it means that the system is up and responding. But this doesn't necessarily tell us that it's capable of doing anything useful, because it might be there's a deadlock in our own code. So what we can do is we can create a couple of endpoints, and those endpoints relate to things like liveness and health. So the liveness checker is a class that implements health check, and basically what it does is it does a little bit of testing. Now, please ignore the stuff about frozen or not frozen, because that's used in a different set of labs. Basically, it generates a name, start time, and things like that. So what I'm going to do is I'm just going to annotate that. Okay, and Helidon will automatically say, aha, I'm going to look for something that is annotated with liveness and run it when a request is received. So it will call the health check, and that, or the health check interface defines a response called call, which generates health check response. I'm also going to do the same on the readiness checker. Now, readiness checker differs from liveness in that the liveness checker will look to see if a class or if the code is capable of responding at all. The readiness checker can effectively say, are you capable of processing a request? Now, the reason for the difference is a liveness checker will tell Kubernetes whether it has to restart your current service. A readiness checker basically means that for some reason you can't respond at the moment, but restarting it won't fix that problem. So effectively, Kubernetes will then check on a regular basis to see whether your service has recovered. Perhaps there's a downstream dependency that was restarting or something. Once that's restarted, then your service can continue processing results. Now, obviously, the readiness checker potentially needs to do something different in terms of looking at downstream services to see whether they're available. And in this particular case, the readiness checker will ask the stock manager, are you available? If the stock manager says yes, then our service is capable of responding to requests. So again, let's just quickly stop these services. Okay, so, right, and restart those. Okay. Right, now we can use a slightly different URL to access this. So we can access the health URL that will report on all of the information. Okay, but we can, if we want to, restrict this to, let's just say, are you ready? Okay, in which case it'll just return the results of a readiness endpoint. Now, you don't have to implement these, but they are going to make life an awful lot easier if you're deploying into a Kubernetes environment. So thank you very much for your attention. Hopefully that's been useful. What we're going to be looking at in the next video is not about how you can write your code, but how you can make it easier for your code to be used elsewhere by the use of effectively self-documenting code, which will generate a description or an API endpoint that you can go to, and therefore a client can see what services your code offers, what the data structures should look like, and things like that. So thank you for your time and attention. As always, if you would like to see the original source code or to do the lab yourself in more detail, the instructions are coming up. Thank you. What you've just seen is based on a lab which goes through effectively using Helidon to create microservices from a monolith piece of code. This lab is available to anybody on the internet. It's originally written to work in the Oracle Cloud, but you can take the source code from the Git repository and run it in your own environment. You can use a MySQL database or other databases if you want to. So what I'm going to do now is quickly show you how to get to the lab. That will include links to where you can download the original template source code and obviously the content of the lab itself. So in a web browser, if you go to bit.ly/go live labs, okay, and that will take you to the Oracle Live Labs starting page. Then search for using Helidon to create microservices from a monolith. Now that's going to return 2 lab options. The overall sequence of videos is based on the extended lab version, but if you don't want to do the extended stuff, you can just focus on the shorter version. You basically just click the launch button, and then if you want to run it on an Oracle trial, you can register for free trial environment. If you already have a free trial environment, you can then look at running it within that environment. You just basically click on that. You can then have access to the web page. Effectively, what you need to do, follow the instructions under getting started and set up your tenancy and set up for the Helidon labs to get this working in the Oracle Cloud environment. Now, if you don't want to use the Oracle Cloud environment, then there are instructions on how to download the source code using in the setup for Helidon Labs section. You'll obviously need to make sure that you've got Java 11 on your laptop. You're going to need to make sure that you've got a suitable IDE and so on. If you want to use a database other than the Oracle database, you can do that, but you'll need to configure the database files so that you can ensure that it will work on the local database, and that's basically through the JDBC and JPA, JTA settings in the meta-inf folder. So thank you for that. Hopefully you will enjoy playing with that, and good luck.